Okay, hi guys, I'm Arvind and I'm responsible for handling part of this computer science course. Now, there's something I want to tell you before we begin. I'm not going to use Turbo C++ because firstly, it goes crazy on my laptop, and also because there are much better compilers out there. The one I'm using is called Visual Studio Express 2012, and you can download it off of the Microsoft website if you want to. Now, I know that some of you will use Turbo C++, so if there's some code in Visual Studio, which is the compiler I'm going to use, that is meant to be written differently in Turbo C++, I'll write that as a side in the comments. So let's begin. In this video, I'm going to introduce you to the notion of an array and introduce you to an algorithm on arrays, an operation, a search operation that's called linear search. So an array in C++ is basically just a bunch of elements of the same type that are stored one after the other in memory. So what we have here on the first line is basically an array of integers, because we have 1, 2, 3, 4, 5 integers that are stored next to each other. We can also have arrays of characters, floats, and so on. So the syntax to declare an array in C++ is ty arrayname open square bracket size close square bracket semicolon, where ty is the type of the data items that constitute the array. So in the example we just took, the type would be int because each of these elements is an int, and arrayname is the name that we give for the entire array. That is, for the whole cluster of objects we have one name, and that's arrayname, and size is the number of elements in that array. So here in the first line we have 5 integers, so the size of that array would be 5. So let's say we want to declare an array to store 5 integers, and let's say we want the array to be called student. We declare it as int because we want it to be an array of integers, student because that's what we want to call it, and 5 because we want it to store 5 integers. So let's say after some processing we have elements in each, we have meaningful elements in that array. Let's say we've stored the numbers 23, 32, 34, 14 and 8 in that array. Each of these elements can be referenced separately on their own as if they were just regular integers. The first element, 23, is referred to as student 0, where because the name of the array is student and 0 is for the first element. The second element is referred to as student 1, the third element is referred to as student 2, and so on. Notice how we actually started counting from 0. That's just how computer scientists count. So the need for arrays is obvious. Let's say we want to deal with the age of 50 people. Instead of creating 50 integer elements, we can create an array of 50 ints. That is, instead of creating 50 separate variables, we can just create one array. So we're gonna study a basic search algorithm that is called linear search. So the idea behind linear search is pretty basic, and I'll explain that to you now. So the idea behind linear search is that we have an array of a couple of elements, let's say 2, 7, 27, 90, 84 and 98 and 72. So we have a bunch of elements, and what we want to do is that the user gives us an element that we want to search for inside that array, and we have to find out whether that element is present. So let me tell you how to do that. So our first line is, as we always do, include IOStream. Well, actually, we say include IOStream if we're using Visual Studio, but if you're in Turbo C++, that would be include IOStream.h, and then the next line is using namespace ::std semicolon. If you're using Turbo C++, you can just ignore that because that's just something that's part of the syntax of Visual Studio. And then obviously we begin our main function, void main, which is where all our main code goes. So first let's declare an array of size 100. Let it be an array of integers, so we write, and let the name of the array be numbers, so we write int numbers 100 because that's the size that we want. Now we have to ask the user how many elements they actually want to use, how many integers they actually want to enter in that array of 100 integers. So we declare an integer size, and we say cout enter the size of the array, and we take in the element size. So if they enter 5, that means that they only want to enter 5 numbers in this array of 100 elements. So they want to enter 5 numbers or size numbers in general, so we have to allow them to do that. For that we use a for loop. For int I is equal to 0, I smaller than size minus 1 plus plus I, we say cout enter element I plus 1, because we start counting from 0, but computer scientists start counting from 1. The user starts counting from, computer scientists start counting from 0, but the user starts counting from 1. So to account for that discrepancy, we have to say enter element I plus 1. And then we see in the ith element of that array. That is, our array name is numbers, so we take in numbers I. So the first iteration of the loop will say enter element 1, and then we take in numbers 0, and the last iteration on the loop will say enter element size, and then we'll take in size minus 1. When we say size, we mean the size from the point of view from the user, not from point of view of the computer scientist. So that allows you to take in all the elements. And now we want a search element, because we have to search that array. So we declare an integer search, and then we tell the user cout enter search element. That is, we're basically asking him what number do you want to search for in this array. So we cin search, and now we know that we have to look for a particular number, and we have a whole bunch of numbers in that array. So the idea behind linear search is that let's use the array I have above. The idea behind linear search is that we look separately into each of these numbers, check if our search element is present at each index. That is, first we compare 2 to our search element. If it's not present, we go next to 7, and then if it's not present, 27, 84, and so on, and we see if our element is present anywhere inside the array. So to compare it with each element, obviously we need a loop. So our loop would be for int j is equal to 0, j is smaller than size minus 1, because that's how j is smaller than just size. Oh no, it's size minus 1, because we start counting, the computer starts counting from 0. So size minus 1 plus plus j. What we want to do is compare our search element with each element in the array. So we say if search is equal to numbers j, then flag is equal to 0, where flag is just a variable that we can use to see if later if the search element is present. Initially, let's say we declare flag with a value of 1. So if the element is found anywhere in the loop, in the array, then the loop will go through it, and if it's present, it'll set the value of flag to 0. So this essentially lets us search through each of the elements in the array, and if the search element is present anywhere, flag becomes 0. So after we do that loop, basically we'll either have a value of flag 0 or a value of flag 1. That is, if our search element is present somewhere in the array, the value of flag will be 0, and or else the value of flag will be 1. We can use this to determine whether or not the array is present. So in the end, we write if flag equal 0, cout search element present. Else if flag is equal to 1, which means that the value hasn't changed, which means that the element is not present, search element not present. Notice that we only say present or not present because for us it's not let's just say for us it's not important how many times the element is present and where it's present. All that's important for us is to see whether the search element is present. So that concludes the code, so we can try and run that now. Control F5. Yes, so I'm just compiling it. Source.cpp. Come on. Yes, no errors. So let's say we want the size of our array to be 4, so we enter 4. Our first element should be, let's say, 13, so we enter 13. Our second element should be 57, let's say 57. Our third element is 81, and oh, there's a mistake here. Our size is 4, but we've only got 3 in, so let me check what that is. Yes, here we say size minus 1, but I is less than size minus 1. I is less than, it should be I is less than size. That means it runs through from 0 to I minus 1. If I is less than size minus 1, it will only run through from 0 to I size minus 2. Even here it should be just size, not size minus 1. So let's run that again. Control F5. Yes, let's compile it. No errors. So we want 4 elements. The first is 12, the second is 53, third is 81, and the fourth is 98, and we want to look for 81. So if we've implemented this correctly, the program should say yes, 81 is present because our third element is 81. Search element present. So the program works. So that's it for now. See you again later.